Well, good afternoon, everyone, and welcome to another episode of Taco Tuesday. Today's topic is all about KV and KS vertical inline pumps. My name is Rich Medairos. I'm one of the senior systems engineers at Taco, and I will be the moderator for today's presentation. The actual presentation will be done by Brett Zerba. Brett will be on in a couple of minutes. I have a few housekeeping things to cover with you folks, but before I get involved with the housekeeping items, let me tell you a little bit about Taco. We are a company that is family owned by the White family, and we celebrated our 100th year anniversary last year. So we've been in business just over 100 years. And John Hazen White Jr. is the third generation of the White family that's currently operating the company. And Johnny has a terrific senior management team headed by Cheryl Merchant, our global CEO. And we have several manufacturing facilities scattered throughout the country. So I'm going to let Brett tell you a little bit about himself in a minute, but I have some housekeeping things to talk about. First of all, this course is eligible for PDH credits, Professional Development Hour credits, and you'll receive an email tomorrow sometime after noon. I think it's usually 24 hours or so, and which will provide you with a link so that you can download your certificate for this course. And also, we are recording Taco Tuesday, and you'll also receive an email that will allow you to access the recording. Again, that's roughly 24 hours from now. A couple of other quick housekeeping items. If you'll notice under the handouts list, we have 4 handouts that go along with this. You could just double click on them. It'll open up a PDF file and you can download and put it on your desktop. So in a few seconds, I'm going to turn it over to Brett, but for those of you that are out there in Taco Tuesday land, if you could just in the questions or chat area, questions area rather, if you could just type in hello in the question area, that way I know that you can hear me and you can see our screen that Brett has up there. I'm getting hellos from lots of folks. Thank you very, very much for that. So Brett, why don't I turn it over to you, and hopefully I haven't missed any items. If you could take it away and tell people a little bit about yourself.
Thank you, Rich. Appreciate that introduction. Hi, everybody. Brett Zerba. I'm application engineer / trainer with Taco Comfort Solutions. I've been with the company 25 years. I graduated from the University of New Hampshire in 1981. Holy moly, imagine that, 1981. Wow. Anyways, let's have some fun today. I recognize quite a few. I looked at the attendee list. I recognize quite a few names, and thank you for sticking with us on our Taco Tuesdays. And by the way, the commercial team, Brett, and Rich and Brett, will be doing a Taco After Dark tomorrow night from 7 to 9 o'clock. Some of you may have gotten an email asking about that. If you didn't, let us know, and I'm sure we can send you a link to that. We're gonna have some fun. We're gonna try to teach you some things, but most of all, we want to have some fun and continue to build relationships with good people like yourselves. So, let's get right into it. Today's presentation, may not last the whole way, but I got a lot to cover. So I want to talk about the Taco line of KV and KS vertical inline pumps, and kind of take a deep dive into them, go over some of this, information associated with them, and maybe talk about some applications. But to be quite honest, most of you know the applications are for chill and hot water and condenser water, heating and cooling, HVAC. Our pumps really move. These pumps move water for the most part, right? You can put some glycol in there, and obviously there's some other additives, but they move water, right? If you want some really chemically rated pumps, you might go to our hydroflow division, but that's another whole discussion for our vertical turbines, and they do a heck of a job as well. So let's get
Brett,
right into it.
Before we get too far, there was one item I didn't touch base on. I did mention that if you have some questions, to type your questions into the question area, but we will pause periodically and answer your questions in real time. And then also Brett will ask me if there are any questions out there. So we don't have to wait to the end to answer your question. So if you have a question, type it in, and then I'll ask Brett to pause for a moment, and we'll see if we can answer your question.
And please ask questions, otherwise Rich will ask me all these questions, you know, and
Yeah, and I have
that's
a
not
list
fun.
of questions. I start off with, you know, what's your shoe size, things like that. But anyway,
When's it
back to you, Brett.
Thanks, Rich. When's it gonna? Here's a question. When's it gonna rain? Because I can see some dark clouds. I live in north of Boston, North Shore of Massachusetts, and they're predicting rain this afternoon. But it's supposed to
Yeah,
get
I'm
rid of the
hoping it does
humidities,
rain because they say that if it rains, we'll get a change in uh,
air
we'll get a
quality.
change in air quality. Yeah,
Yeah,
someone
the
said it's
humidity's
raining
out.
in
We're
North
getting rid of the
Carolina.
humidity. There you go. All right, so let's get into it. KV and KS pumps. Well, one of the first things I want to make sure everyone understands, and I'm sure most of you do, if not all of you, when we talk different pump styles, right, and we talk inline pumps, right, and believe it or not, many moons ago, this confused me a little bit. Inline pumps, splitter close coupled, and we'll get into that. They're differentiated by shaft orientation. So you'd have horizontal inlines on the left side. They happen to be our 16 and 1900s. And then our vertical inlines, which I'm going to talk about or dive into today, are on the right-hand side. Our KS is our split coupled, and our KV is our close coupled. And some people may call direct coupled, close coupled, and we'll get into the details of that. But nonetheless, just so you understand the styles that are out there as we get going. So let's talk about the KS pump first, okay? And like I said, it's the split coupled. So the motor driver, whatever you want to call it, right, is separated, isolated from the system, from the pumping system, with a split coupler design. And you can kind of see that in that picture with the cutaway. Actually, it's not a cutaway. We just don't have the coupler guard on there. So that other piece that is shiny, with three kind of holes in it, that's an aluminum coupling. And some of you have been to our facility. We actually manufacture those out of bar stock right at our facility in Cranston, Rhode Island. So this is a whole machined, fitted up piece, bolted up. You know what that means? That means when it gets into the field, it doesn't need to be realigned. Right? It's all properly aligned. So that's a big difference between those base mounted pumps that many of you, if not all of you, are very familiar with as well. So I think that's one of the reasons why we're seeing increased sales in vertical inline pumps. There's other reasons, and I'll talk about them as we get going, but that's one of them. I can only imagine if I know we have lived through some alignment issues on some base mounted pumps. You know, it's always the pump manufacturer's fault. We understand that, but nonetheless, once it's resolved, it can become quite the issue. But these bad boys here, once they're installed, that alignment, right? When I talk alignment, I'm talking about the shaft, motor shaft, and the impeller shaft, right? There's two actual shafts that meet up there, and they have to be within alignment of 5 thousandths on base mounted pumps. Here, we don't have to worry about that. So you don't have to call in that alignment guy that brings in his machine or whatever to align it. So something to be considered. As you can see on the right-hand side in performance data, these KS pumps get up pretty big, right? Flow ranges, they start relatively small, but they go up to well over 10,000 GPM. With a pretty good size head range, as you can imagine there. The standard working pressure is 175, so you know that's what 80–90% of our of the business that's out there. But if it's a real high rise or something like that, maybe you might want to up it to the 300 psi G, which is an optional. And by the way, at our facility in Cranston, we pressure test the pumps after they're assembled. Not flow and head test, okay? That's a whole different animal. We've done that initially, but not once the family is out there, we have to meet the curves, and we do. But nonetheless, we do pressure test them to 1.5 times working pressure to ensure there are no leaks or porosity in the casing. So That is done right as the pumps are going through our assembly line. And we actually do assemble them in an assembly line. When I first started there some 25 years ago, actually 24 years and 8 months, 9 months, I can't keep, it's October, whatever the math is to get to October, it'll be 25 years. We used to have 6 or 8 tables where a basket of parts would come, and one guy would each pump assembler would assemble a pump, and then someone would come and take it and move it down the line. Now it's actually an assembly line. So that's one of the internal things that we've done over time with our manufacturing team, engineering team, to the Six Sigma to increase production. So something to consider there, or something to realize. You can see the horsepowers, right? I believe the biggest one that we've actually sold was 450 horsepower, but we are offering a special. If you order 3 600 horsepower KS pumps, Rich and I will send you a gift certificate to what's our gift certificate of the week? The sub shop that you like, Rich.
Subway.
Subway. There it is.
Yeah, you can get a 6-inch sub there, and depending on what day of week it is, you can get a special.
Now, obviously, I'm just goofing around a little bit here, but nonetheless, they do get up pretty big, and they get pretty heavy when they get that big, so you can only imagine. And then our biggest flange size, when we say sizes, we're talking about the flange sizes, goes up to 14-inch. That's not the impeller diameter. Our impellers, I know we get 17. We might even have a 19-inch, so they get pretty big as they go. So that's kind of some of the general information on the KS pump. Here's the KV pump. A little different, right? Closed couple design, right? So you can tell the difference, right? You don't see that. You don't see this piece here, right? The little stand, the little support stand with the coupler, and in this case, the motor is bolted right to the impeller and to the top of the casing as well. So that's what we call a closed couple design in HVAC hydronic pumps, and it is a standard NEMA JM motor that's used here. But notice that these pumps, let me get my little bouncy spotlight here. These guys only go up to 60 horse, okay? So they're a lot smaller in nature, all right? A lot smaller, and you can tell, right, we only go up to 8-inch here, and the flow rate is like 2650. So really the range is a lot closer to the base mounted. I think our base mounted goes up to just over 4,000. So it's kind of in that range. But the other stuff is pretty much the same: head range, temperature, working pressures, and all of that. But here's a comment from me, and some of you may already think about this or know about this. Although us pump manufacturers offer these pumps up to 60 horse, let's think about that. Shame on me, and I was thinking about this when I was putting the presentation together to get the motor weights. But let's think of maintenance, right? So sooner or later, these pumps have to be maintained. If you've ever been involved or gone into a mechanical room or been to our facility and you see some of these pumps and how big the motors get, personally, and many of our reps, right? Yes, I work for Taco, but I truly believe our rep force is the best in the business. Anyways, many of our reps would recommend maybe 10 or 15 horse max on a KV pump, and then go over to the KS pump where the split couple, just for that reason, from a maintenance standpoint, because, hold on a second. This pump here, you can actually change and access the seal without moving that motor, right? You don't have to move that motor. You do have to take this apart right here, but you don't have to, and to take the cover off, or this little piece right here, but you do not have to move that motor. So that's a big deal. Here, somebody has to lift that motor out. If it's a smaller motor, no big deal, right? You can get it out of there or whatever. But the bigger the motor, the more equipment or whatnot that you may need to do that. So something to consider, and just keep that in mind. So on a KV pump, think about it. You do need some headroom over the top of it, right, to lift that up at some point in time, once you start unbolting things to access components there. So something to consider once you get it into the mechanical room or on your drawings or whatever. And one thing I always like to mention, we have different model numbers, right? So I may have a KS 3007 with a 10 horse motor and a KV 3007 with a 10 horse motor in the same speed, 1760 or whatever. The performance of those two pumps is identical. Okay, so just keep that in mind. It's identical. So that's the curves for these two pumps are identical. So that means that the wet end in here, in the internals, are identical. So hopefully that all makes sense. But it is good to know this stuff, right? I know you're on the other side, right? Maybe you may be an installer, a contractor, or you may be an engineer. But the more you know about products, in my opinion, the better off, and it's just good. It's good knowledge. And to be quite honest, yes, this is a green pump I'm showing you, but many of the components I'm talking about and many of the things I'm saying are relevant to the red and blue guys and any other pump color that's out there. Yes, there's differences. Don't get me wrong. Yes, there's differences, but nonetheless, many of what I'm talking about here it overlaps amongst us. So here's a little detail of what you can kind of see inside of there. So there is a stainless steel shaft, right? This item here is a stainless steel shaft, and then we do have a standard seal design, right, which allows flexibility. We have a standard seal option, and I'm going to show you that shortly. But because of the seal design being standard, you can interchange other seals in there, and that does happen in the field. Maybe for whatever reason they start putting a different chemical in there and they're getting seal leaks. You can very easily, well, relatively easily, I guess nothing's that easy, but relatively easy, you can upgrade that seal from the standard type as well. And similar to our base mounted, I know some of you folks sat in on the base mounted deep dive a couple of weeks ago or last month. We have pressure tappings on our casings as well, so you can put some gauges there as you so choose. We do offer 250-pound flanges. They are available as well. We have a casing drain down here as well, as you can see. And down below here, it's a little hard to see, and unfortunately I don't have a picture of the underside of a pump. It's machined, right? And there's tappings there, so that allows you, as the pump gets bigger, to actually relatively easily bolt something to it as a support stand, if you'd like. So they're already there. You don't have to drill into the pump or anything like that, right? We do have an optional wear ring capabilities if you'd like as well. And then if you remember the FI discussion, I talked about our impellers. They're very, very highly efficient. And I'm going to show you some pictures of that further down into the presentation as well. But they're very, very highly efficient impellers, very, very smooth. We're very, very proud of our impellers. That lost foam process, and you'll see what I mean by when we get to that point. They are bronze. We do offer stainless steel impellers, but we haven't standardized on those. But nonetheless, they are available. And we do have support stands that you can add to your purchase order or specify or whatever, and highly recommended for once you start getting above maybe 20, 30 horsepower and it's going to go down onto the floor. You don't want to bolt this hard to the floor. And I'll talk about that from an installation standpoint. So that's kind of some of the details of a KS pump. And a lot of the details are the same for a KV pump. So I'm not going to show you that picture as well. It's just the motor's down lower because it goes right into the impeller. So something to consider there. But everything else, like the mounting holes and whatnot, and these pressure taps, and the casing's the same. So the casing's the same between the two. So that's pretty much the same. So here's the material of construction, and again, it's the same for the KV. I probably should have said KV/KS pump material of construction, and this is common, right? It's really the same material breakdown as our FI pumps. Something to consider there. We do have that optional wear ring. As you can see, the impeller is bronze, the casing's cast iron, and that's the actual call out of it there. If you go to if you go to 250, it is a ductile iron because it just has to have a little more oomph to it. Excuse me, and then the couplings, and there's our standard seal is a ceramic EPT, pretty common. It's a John Crane type steel, but we do have some other options there, and we actually have some others that are listed, or your Taco rep can get you some more information on that. And we do have that flush line that we feel is very, very important to keep that seal flushed, and so it flushes away any grit that gets into there, because seals do not like grit or grime or anything like that. And for the KV pumps, currently we do offer an NSF 61. Currently, our KS pumps cannot be qualified to. We're not offering them as NSF 61. There is a global issue for getting materials for one of the KS components, so we can't do that currently. And I'm sure many of you, if not all of you, have had some conversations with other manufacturers about some of their delivery issues, or maybe you tried to go buy a car recently. Actually, a friend of mine, my brother-in-law, is trying to negotiate with a car dealer, and the car dealer is not even negotiating anymore. That's which is unheard of, right? Oh my God, I can't believe it. So getting some material for different products is not necessarily the easiest thing in the world. So pretty standard material of constructions there, as you can see. But so if it was an NSF, and as I mentioned, the KVs, you can still get them as NSF. The impeller would be stainless steel. You can see that difference right here. So something to consider as you go. Rich, we got any questions? Are we doing good? Am I talking too fast?
Actually, a question, and maybe you already answered it, Brett, came up just before this group of slides, before the cutaway. And that was, can you mount the pump with the motor horizontally?
Great question. I am going to cover that, but let's answer it since it came up already. The KV pump, that's this one, can be mounted horizontally up to 15 horsepower. Above 15 horsepower, the KV pump cannot be mounted horizontally, and the KS pump cannot be mounted horizontally at all. So hopefully that answered that question. So that's the answer. Good question though. And here's the the operating specifications. And again, the flange is a standard ANSI class 125. And you can see the rating there. It does go down a little bit from a pressure standpoint once you get above 150, but really it never goes below a working pressure of 150 or 140. So even at 300 degrees. So something to consider there. We do, and if anyone had sat in on the FI talk, the base mounted, I actually sent out some brochures on these micron filters, the Kuno and the Kynar. Some of our engineers that we deal with, our reps deal with, that's actually in their specs. So every time they quote a pump to them, boom, they have to include that. It's probably an engineering firm that had some issues because of grit getting into it, and who knows what with the city water or bad filtration or whatever. So they just include that filter, and that just helps seal life, as you can only imagine, as you go. And we're looking at this temperature range, 250 degrees. So I don't see an issue there in that regard. I think I actually have a mistake here. But anything above 250 for operating temperatures, we recommend a cool flush line is required, and 225 and above. So and really, that's just helping the seal, right? I mean, if it was clean water, the seals would last a very long time. John Crane is a very, very good company, and many of us pump manufacturers use them. So it's not like there should be an issue there, but nonetheless, a lot of times, and we've seen it, you've seen it, many of us have seen it. There's just stuff in the water that affects seals, so something to consider there. So self-sensing pumps. So take these two models right here, the KS pump and the KV pump, actually our FIs, and shame on me for not talking about them, and CIs, we also offer them as self-sensing pumps, all right, models SKS and SKV. And here's some pictures of them here. There's the KV, there's the KS. And what, hopefully some of you know what this means. One of our big competitors north of the border has talked about these for many years. The boys in Toronto, and they promote this on a regular basis, and we've had them out now for 8 to 10 years. So it's nothing new. But what this is it's an integrated drive. Integrated, right? It's mounted to the pump, but it's integrated. And that drive is so intelligent, it responds to system demand changes. So if think about a fan coil system with control valves, and they're all wide open, you're hitting design point, boom, that pump's going to deliver that. But now as the day goes on, the sun goes to the other side or whatever, and some valves start to close, right? Normally, a signal would be sent to the drive, right, from some type of sensor out there in the system, and that drive would slow down, right, or the pump would slow down because the drive would tell it to. These pumps don't need that. They do not need that. No remote sensors, no complex wiring. All the intelligence is built into the drive. Now we have a whole hour presentation. Rich does a heck of a job on the presentation to demystify self-sensing. So if anyone ever wanted to see that, you can go to our website. I'm not going to get into that demystifying here. I'm going to get more into the details of the products and whatnot. But I wanted to at least mention this, that these are becoming very popular in the industry. And we all off. Whenever I say we all, excuse me, I got to take a sip of water. I'm talking our competitors. They offer something similar to it as well, and it's really becoming something to consider and something to think about out there. Us pump manufacturers have had to do a lot of testing for these models with that drive mounted to it in order to do the lookup tables, and again, it's hard to understand all of the details, but there's a lot of intelligence in those drives. And those drives that you're looking at are Danfoss drives, and our two main competitors use Danfoss drives as well, because that's the drive company that has the brains to be able to do this stuff. And something else that's neat with this, it measures and displays flow and head right on these screens right here. So if any of you, and I'm sure many of you have been in mechanical rooms, and you may struggle to find a pressure gauge or a flow sensor that's working, well, this one displays it right on the screen right there. It displays other information, but it does display flow and head. How nice would that be? You walk into a mechanical room, boom, and there it is, showing for you is right there. It's intelligent enough, and the internal workings of it. It actually measures system resistance, actual system resistance. And ours is a differentiator compared to most of our competitors. You can kind of see it right here. We have vibration isolators. The lead engineer, design engineer, R&D engineer was worried about these guys vibrating the drives on the pump. You know, but pumps do vibrate a little, especially as the motors get bigger. So he did some testing, and we are 3 to 4 times less because of the isolators, you know, in this bracket and whatnot, and that mounting surface, than the recommendations from Danfoss. So something to consider there. But that is a nice feature of these self-sensing pumps. And then it's very hard to mention this without getting into it a little bit, but we do have system balancing with self-sensing Pro Balance. Do it yourself. I know some people, Rich and I have done it at our factory, and actually I've been on one site where we were able to do it pre-pandemic. I haven't been out much since the pandemic. I've become a hermit. Not true. Anyways, but you can relatively easily talk to or press some buttons and help balance the system and reset the control curve. And there's a whole detail of a startup on that, but it's a really nice feature, and it helps the end user, the actual person that or company, school, hospital, whatever, save the energy, save as much energy as they can. So that self-sensing with Pro Balance is something that we're very proud of, and it really is a differentiator for us. So that's a quick introduction to our self-sensing. I'd be remiss if I didn't at least mention it when I'm talking about the KV and KSs. So I'm not going to get into it that much, but nonetheless, they are available, and they are becoming a growing market. And one thing that I like to mention to folks, and, you know, I'm a very practical guy. I tell my wife I'm a simple person. I'm a practical, simple person. But what I see with this product is people that specify it and put it in and has it work on a project, they keep specifying it. So what's that tell you, right? Change is always something we struggle with, right? Us engineers, we like to do the same thing, you know, over and over and over and get the job done. But they are seeing some benefits, startup benefits, getting off the job quicker, and all of that from using this type of product. So something to consider. And like I said, our TACO reps can get you a bunch more information on the self-sensing if you'd like. So here's some tidbits of KV and KS pumps. Oh, I already said this one. I told you it was going to come up. So the KV pump, as I mentioned before, up to 15 horse can be mounted horizontally, and then is unacceptable for the KS. Okay, so just keep that in mind. Pumps with smaller motors, and I've seen this, may be suspended in the piping. And I'm going to show you some pictures of that, as long as the pipe hangers are strong enough to support the motor. Excuse me, to support the pump and motor, support that, and they're located next to the pump. And I'm going to show you some pictures of that very, very shortly. So we have seen that, and something to consider there. With larger motors, you know, what's small, what's large. Maybe that 20 horses, the cutoff, from my perspective. Maybe some people are more uneasy if it was 15 horse, but they should be attached to a support. Utilizing those tapped holes I talked about that are underneath the pump, the main part of the pump, or in the bottom of the pump. And I'll show you some pictures of that very shortly as well. Piping loads, and this is common for all HVAC hydronic pumps and pumps in general, should not be applied to the pump. They should not. You need to pipe away. You need to support it someplace else. And then these pumps need to be allowed. You can't move with the piping as the piping grows and whatnot. So this is all spelled out in those instruction sheets, the I&O manuals that you have in much greater detail. But these are little tidbits that I wanted to at least mention to you as well. So do not rigidly connect the pump to the floor, right? If you're going to put it on a stand, let that stand slide just a little bit as it sits there. And this isn't just a pump KSKV pump tidbit, but I recommend, and maybe it should be in your specifications or whatnot, start the piping, pipe away from pumps, right? Don't pipe to the pump and then use a big screwdriver to align those flanges up, because something bad's going to happen. So pipe away from it. And then I mentioned this before, and I like to hit this home again. If you are using eccentric reducers, and they're used a lot, on the suction, install the flat side uppermost. It helps the flow get into that pump. If you look at the casing and whatnot, so it helps that flow get in there. So here's some tidbits. I didn't know what else to call it. Maybe someone could type something in there and have a better word for what I should have used there. But nonetheless, here's some important stuff. And like I said, the I&O manuals have a lot more information than I could. If I kept typing that up here, we'd never leave a page like this. So Rich, I need a break. How we doing? Any questions?
I think we're doing good. Let's take this opportunity to see if any of the folks out in the audience listening have any questions. Has anybody anything that they've seen so far they have some questions about? I don't have any new questions as of right this second, Brett.
Great. And then the last
wait a
one
minute,
here.
Comes one.
Oh,
It said, would a floor mounting on a concrete pad be acceptable? What? Let's see. Would that be fine for vibration isolation? Let me try repeating that question I kind of fumbled over the words, Brett. Would a floor mounting on a concrete pad be acceptable? Would that be fine for vibration isolation?
Yes, and I'm going to show you some pictures. I think that's what I'm going. Yeah, I'm getting into that now. So let's see if I answer that question as we go here very, very shortly. The
Now, we
last
do
one I
have
forgot.
another question, which you may
Okay.
be covering in the near future. Will you cover controlling the pumps?
Well, a little bit, not really. They're controlled. Well, let's see. How can we answer that, Rich? They're controlled the same way as a base-mounted pump. Um, uh, uh, with if you
Well,
don't
I
have,
think what we can do is we could table that question, and we'll give it some thought before the end of the presentation, and maybe we could provide some. Let me go back. The person that asked the question was Steve, and maybe Steve could elaborate a little bit on what he means by controlling the pumps while we go through answering that first question. So why don't
yeah,
we talk about the mounting, and then we'll get back to
yeah,
Steve if he can kind of
okay.
elaborate a little bit.
I do want to mention this here because many, especially on chilled water applications, you see some insulation, and this is common. Don't insulate any part of the motor, right? So you only insulate up to the top of the cover of the pump. Don't insulate any of the motor, and that makes sense. I think all of us can kind of figure that out as well. So here's a picture of a potential way, and this could be a KV pump as well. Okay, so these pictures are common for both. So this is one that you're just the hanger supported pipe mounted. So we were talking about different sizes, up to 10-inch flange size. These inline pumps can be mounted like this. So you can see nothing is touching the floor. Okay, nothing is touching the floor. You just have to make sure that these hangers are sized correctly, right? Because normally, right, you think they're just holding pipe, but nonetheless, now all of a sudden they got to hold the weight of the pump and motor assembly as well. Okay, so something to consider. And we've seen many installed this way. It helps floor space possibly. You know, I've seen them up higher. You just got to think about maintenance and some accessibility at some point. But nonetheless, here is one way you can mount them up to a certain size, and this is our recommendation, and it's spelled out in a lot of our literature as well. And here, so this is something that we've seen before for smaller pumps. You typically 15 horse and below, they can be mounted even closer to the ceiling. Okay, and you can see some of the hangers here and whatnot above the finished floor, even closer to the ceiling. And then you put the multi-purpose valve on the right angle on one side to help the pipe go straight up, as well as the suction diffuser on the other side. It's a rear pullout. That's what this means, rear standard pullout. So the screen that's in here pulls out to this side, so you need some clearance over here as well. But nonetheless, here is a possibility of a different way, up to and including 15 horse. Maybe you can tuck it and save some more space, right? You think about your mechanical rooms. I've talked to many engineers over the years, and a common theme is mechanical rooms aren't getting any bigger. They seem to be getting smaller by the day. So nonetheless, here's some possibilities to possibly save it on maybe a smaller type of system or whatnot. And again, you know, you have to think about maintenance, but if you put a KS pump up there near the ceiling, that motor doesn't have to be touched, doesn't have to be moved, and that seal can be, you know, someone could climb a ladder or one of those scissor lifts or whatever. Probably not a ladder, right? Oh God, I shouldn't have said that. OSHA people are going to get mad at me. I should not have said that. Strike that from the conversation. But some type of scissor lift, a much safer way to access it and maybe access the pump to change it that way. But obviously, us engineers, we have to think about that and don't cringe, although it doesn't always happen. But nonetheless, here's a possible way of doing it as well. So this is one that a possible way of mounting it to the floor. Okay, so you can put some pipe stools attached to the bottom of the suction diffuser and/or multi-purpose valve. You know, you got to have the right pipe lengths and whatnot, but nonetheless, you still want to make sure those pipe hangers are sized correctly. But nonetheless, here's another potential way you could mount it similar to the other one, but this is much closer to the floor. And maybe some people say maybe they get a little worried by not having supports there. And really that isolation pad, that's a waffle type, which means it has a kind of a waffled bottom to it that rubs on the floor. So it's not bolted to the floor, but it's really just a pipe support. And you can see in this case, nothing is holding this down like a base mounted pump where you actually bolt it to the floor. So, something to consider as you think about stuff like that. Here, and so if you look at this picture, right, we show a straight run here. There's a, which way am I going? I got to go the right way. So here's a different possible way to save more floor space or save space in the mechanical room. You put a long radius elbow and take this multi-purpose valve that was right angle and change it to a straight run through. You can do that with our multi-purpose. God dang it, go the right way, Brett. So now you can save a little more space here, a few more inches, but that could make the difference on a project as well. So here's a potential way of saving a little more space, discharge elbow for minimum footprint. So something to consider there, and as you think about it. So here's another possible way: saddle mounts. We're ceiling sport; it's not practical. Straight run of pipe. I'm just showing you different potential ways, and this is probably more apt for a cooling tower near a mechanical room, or where ceiling support is not practical or something like that. But it gives you ideas of how it can be done, and that's just a saddle support holding that piping there. Pretty straightforward as you go. But once you start getting to bigger pumps, and to be quite honest, I am talking mostly smaller pumps here, okay, for the most part. If you want more information on once you start getting to the maybe 50, 60 horsepower and above, you really need to read I can't do it justice in an hour presentation, okay? But nonetheless, here's some ideas here. There's our mounting base, or you can see someone mentioned an isolation pad. You can put that right on that base. That's that 6.1A up above A16A. So something to consider there from a little support when it's touching the floor. Or you can get a support stand from Taco as well. So some idea there as you start thinking about it. And then we've also seen people bolt things up to the flange here. We used to actually sell this product, but we don't anymore. These are stanchion plates with isolation pads. So that's another potential way to mount it to the floor. And then you could do the, whatever piping arrangement you wanted, but nonetheless, but don't bolt it to the floor, but nonetheless, it can rest there with those isolation pads. So something to consider there. And this one here, I wanted to touch upon it because I know some of our guests are worried about seismic. I would suspect, and our reps in California or our office, our engineers at TACO can help you with some seismic calcs if that ever was required. But nonetheless, you can use one of those snubber type designs, isolating it from the structure, right? So something to consider there. In case of that seismic event. But nonetheless, you do have that capabilities, or it can be done with these pumps in that regard as well. And this is the last picture. I know you're all getting sick of pictures as you start looking at this stuff. But nonetheless, here's just another way. Groove piping, it's a little different how you might want to support it. You got to have a flange adapter, locking devices, or welded pumps to prevent the possibility of pipe-mounted pumps rotating in the piping. So there's different ways there, and you get more information on our stuff, but I did want to at least show you some of these to pick your interest and give you some ideas of how your details could look, or as you talk to contractors or whatnot. So some stuff to consider there. I went through quite a bit there, Rich. Did anyone pop in any questions? Hopefully not.
Well, Steve came back and he qualified a little bit about what he was asking about for controls. And I think, Steve, the best way to answer your question is that when the pump is, excuse me, when the pump has But we're talking about the larger commercial pumps. These are not ECM type pumps, where many of the ECM pumps have integrated controllers. But these are basically induction type motors, and in order to control the pump, if you're looking for a variable speed pump, you'd have to have a variable speed drive, and the drive that we offer can accept a 0 to 10 volt or a 4 to 20 milliamp signal from a building automation system. So if you have in this case, Brett is showing you the self-sensing pump in this photograph, but the self-sensing pump or the pump with just the conventional drive without the self-sensing function, we offer it in the same basic configuration, the mechanical configuration. So if it's a non-self-sensing pump with a Danfoss drive, it would accept the 0 to 10 volt or a 4 to 20 milliamp signal. And there are also, if you specify our pumps with our drives, the drives do come with a lead lag functionality. So if you have an external signal to control the speed of the pump, for example, you can also have the drive determine which is going to be the lead pump, and which is going to be the lag pump. So if you have two pumps that are sized for 100% of the capacity, one's operating, the other one's in standby. If one should fail, the second one will start automatically. You can also rotate the pump, perhaps on a weekly or monthly basis, in order to ensure that you have even wear on the pumps, equal hours of operating time. So hopefully, Steve, that answers your question.
So most, how can I say this? A lot of the pumps that leave our factory leave looking like this over here, without a drive. So now the end user or the contract itself or our rep or somebody in most applications sells or supplies a drive to the project. Wouldn't you say that was true, Rich?
Yeah, I think the overwhelming majority of pumps today, in terms of their final installation, are using variable speed drives, whether they
So
come from us or whether they're provided by a third party.
right. And so that control is pretty straightforward in our industry, and it's been around for many years. And I think it's even driven by ASHRAE for savings and whatnot. But hopefully that answers the questions on controls. Great question. Thank you very much, Steve, for sure. Whoop. So here's some problem analysis, and I'm not going to go over them all, but nonetheless, it is, be careful during startup. Make sure things are. I mean, our tech supports gets some questions. Rich and I get questions from the field, and to be quite honest, the question is very, very. It sounds very, very complicated, but if we don't start at the beginning and start making sure all of these things are taken care of, the impellers in the right direction, is there water in the line, are the valves open and stuff like that. Yeah, how many times, Rich, is it a relatively simple answer to a very difficult question, if you know what I mean, right? When an
Yeah, I agree.
analysis, I mean, sometimes, I don't want to make any light of it. We all get, and I've got flustered on job sites before, you get a little overwhelmed, but nonetheless, here's some problem analysis, and this is available on some of our literature as well. The other thing that I like to mention, and I mentioned this during our FI, is eLink TACO connectivity. And this is a differentiator for us, and we're very, very proud of it. It actually won an award at ASHRAE a few years ago. And what it is it's, you can see where it's located. These are base-mounted pumps on, but this is, it looks like it might be a CI. It could be a KV, and you can see where it's mounted here and here, but these are NFC tags for product info and support. They're just a green tag, but that tag allows you to use your smartphone and to put your camera up against it, or you have to be in a TACO app, and boom, all of a sudden it downloads product info and support, such as parts and documents, product profile. I'm showing a tank here, shame on me, but nonetheless, it's the same for all of our equipment. parts and documents, so you can get an RP list and all that just from this tag, this little tag that's shown there. The sales rep, you know, that the order went to, or the sales rep that ordered it through our facility. You can get emailed CAD and Revit files. And shame on me for not mentioning this far into the presentation, but all of our KS and KV pumps have, you can download from our website a CAD or Revit drawing for any of those products if you'd like. To be quite honest, I'd make my rep do it, but that's another whole issue. Oops, sorry, reps, I didn't mean to throw more work at you. But nonetheless, that information is available, or you can get it right at the pump now, or the product out there as well. And then we do give you a phone number for contacting technical support. And as long as it's during working hours, a person actually answers the phone at Taco. We have a director of what's their director of first impressions is their title. What a great title. Actually, there's a couple of them. Anyways, nonetheless, that's information's there. So that is our eLink connectivity, and almost all of the commercial products have that, and it's more than one. And I'm actually going to show you a picture of it as well.
So Brett, a quick question just popped up. How long has the eLink tag been in effect?
Well, I know we lost last year, but it was still in effect. I think this is year 4 now, Rich. Am I correct in that?
Yeah, I think so. I think it's 4 years now. So
yeah. We got a new ERP system. Is that what they call that? The computer system? And whenever we got that new ERP system, that's when the tags come up. Unfortunately, you can't go backwards. Okay, it's only forward, but you can't go backwards. So I'm sure by now you're starting to see it out on mechanical rooms, or out in the world, real world, I'll call it. But nonetheless, at least 4 years. This is probably year 4 of it. The years are flying by, Rich. I'm going to catch up to you pretty soon. DOE requirements. The Department of Energy, and this is over 1.5 years old now, has put on some energy requirements for TACO products, actually HVAC hydronic pumps. And 2 of the products that I'm talking about today are affected by that, the KV and KS pumps. So we've had to upgrade their design to meet basic requirements put forth by the Department of Energy. And here's some of the details of it. 1 to 200 horse, so anything above 200 horse we didn't have to. And then so that's the range, and here's the speeds, only the 18 and 3600 nominal speeds, so that 1150 or 1200 nominal speed does not include that. So most of our KV, to be quite honest, that's most of our KV and KS is that range, 1 to 200 horse, to be quite honest. And here's actually the eLink tag. It's just a little rubber tag, and it's a chip, and it has all that information scanned right into it. But this is what the all pump manufacturers are required to put onto their tags now on pumps. The actual shop order, that's the DOE product number, so you can actually find that number at the DOE website. Some link that you could do it, and then we have to include the PEI, when that's the actual performance rating of the pump that we tested there. So I'm not going to get into it too much, but nonetheless, since January 20th of 2020, the beginning of last year, we've had to meet this requirement. I always tell folks on this side of the fence, and I've said it more than once, to cover yourself, put it in your pump specification. All pumps must meet DOE requirements. It's almost a statement that shouldn't have to be made if you think about it, because we can't sell it, or technically we're not supposed to sell it, and we don't. TACO doesn't, that's for sure, in the United States. But nonetheless, then you're covered, right? And so if someone ever says something to you, well, it's in my spec. At least you got something to fall back on. Anyways, I did want to at least touch that from our labeling standpoint. I went through this in great detail a month ago, so I'm not going to spend as much time on it, but it is a differentiator, so I want to at least mention it. This is the loss foam impellers that we offer, highly efficient, and you can kind of see it. And if you've been to our factory, and actually held these or seen me hand them to you to hold or pick them up. They're very, very smooth. And it's just the process that we use, and it really did help us with our efficiency ratings on our base mounted and our base mounted / end suction pumps and our vertical inline pumps. So that's a picture of our high efficiency, and it's the lost foam process. I'm not going to, like I said, I talked about this a lot the last time. So that's the actual impeller. And believe it or not, our R&D engineers send a 3D model to the impeller company, impeller manufacturer, and they take it in that, and they make from that, this tooling. It's like a 3D printer, I guess. If you think about it, makes that foam piece here, and that's what's actually, there's a couple pictures of the actual impeller there. Actually, the foam prior to casting, and then we put it on a tree, and they put it in molten, and that in the hot molt evaporates the foam, and that's what comes out. So this is actually in a sand. That barrel has sand in it, and that tree of stuff. So very, very smooth, higher efficiency hydraulic, no tooling wear. So it's really, really a great process, our lost foam process. And if you think about it, that sand cast impellers, over time, it's a copy of a copy. I don't need to get into that in too much more detail. Rich, I'm going to get into some piping stuff. We're kind of getting near the end here. Do we have any other questions?
We don't have any new questions that have popped up. We're just about out of time. We got about 3 minutes left.
Yep.
So yeah, why don't you touch base on this stuff and then we'll wrap it up.
All right, super. So here's some basic rules of pump piping. Keep the suction. I mean, I don't like reading things 100% what's on there. But take a picture of it if you'd like, or something like that. But keep the suction piping as short as possible. I mean, that's one of the biggest things we can recommend. And I know it's not always possible, but boy, don't do any ups. Don't have any ups and downs going into the pump. The pumps really like laminar flow, nice smooth flow coming in. Especially these HVAC hydronic pumps. We say 5 to 10 pipe diameters. Nowadays, most people put a suction diffuser in there to save space. And I know a very smart pump engineer, one of the smartest I know, that says that was the worst invention ever is suction diffusers. I think people, my good friend Rich knows who I'm talking about. But nonetheless, here's some straightforward stuff here. Keep the air pockets out of it and stuff like that. Pipe away from the pump, stuff like that. Pressure gauges. I mean, personally, I would put one on. My details on my drawings would show one on both sides. But man, you got to have at least one in there. And make sure it works too. But nonetheless, there's really no reason not to include it. And I'm sure it is included probably on 99% of the detailed drawings that I review. But really, it really does help us diagnose problems, or our rep or anyone else that goes out there can see it. And what happens sometimes if you have two, right? One on the suction and discharge, and you go out there and one looks like it's a problem. I've seen my good friend Rich actually take one off the one. He goes, I bet you one's working and one's not, and he flipped it, and sure enough. So see, if you have two out there, we might even be able to diagnose the problem even quicker. Flow control. Use a valve on the discharge side of the pipe for flow control. Don't use one on the suction side. That's a real no-no. Obviously, you can control it with VFDs, and to be quite honest, I think that's what most pumps are. I mean, we can get into a whole discussion about impeller trims. We have the family of curves for pumps. We have a maximum impeller of 11 inches that fits into pump. A minimum is 8 inches. Should you buy the impeller close to the 11-inch? Should you buy it in the middle range or down at the bottom? That is a whole discussion, and there's positives and minuses in each ways. And we trim our impellers at our facility. We trim the impellers per order at our facility. Most of our reps trim impellers as well. We rebalance them as well, but it all depends on the design point, to be quite honest. But that's another whole discussion that we could get into for well over an hour, and there would be so many sides to that coin. I wouldn't even be able to keep count. And then we recommend, or maybe put in your details, use a gate valve instead of a butterfly, right? The gate valve doesn't add any resistance. That butterfly could add resistance. And if you think about the butterfly, right, it's actually got a panel in there or whatever you want, a wafer, and that could cause something to hang up in there, which would be very, very critical at suction. Okay, so something to some small recommendation, but nonetheless something to think about and maybe discuss with others and consider as you go and whatnot. And these centrifugal pumps, I can't say it enough, really work better without a surge-free laminar flow, smooth flow going in, and just keep it that way. Or try to take that out of it, reduce as much turbulence as you can, and it helps the life of the bearings, the seals, and other components of the pump as well. Here's a good idea. We don't stock a lot of repair parts. Some of our reps are cringing right now, and that helps. That amount of pump, that amount of repair parts takes care of all those pumps that you see there as well. And Rich, I'm done talking, and everyone out there is clapping. Yay! He's finally shutting up. Oh, stop it talking. And it's 1 o'clock.
No, I don't. I think it was great. I don't have any new questions before Brett and I sign off. Does anybody have any questions out there? Any last minute questions they'd like to ask? So some folks are saying thank you and they're moving on. So at this point, Brett, why don't you say your goodbyes and then I'll close things up.
You know what? I appreciate everyone's time. Thank you very much. Hopefully you got something out of it. One tidbit, or if you pick out, the way I look at life is if I pick out one or two new things each time I hear somebody teach me something, I'm happy as heck because my brain just can't hold too much anyway. So hopefully you got something out of it. I appreciate your time. And by the way, if you don't know, these Takeo After Dark sessions, we actually have it scheduled for as long as it takes, roughly 2 hours. But the first hour we're going to talk, but the next we're just going to answer any question that comes up, HVAC hydronics. So think about stopping in and visiting for a little bit if you'd like. So thank you for your time. Rich, take it away.
Well, thanks, Brett, for that great presentation. At this point, I'd like to thank everyone for participating in today's Takeo Tuesday. Look forward to seeing you on future Takeo Tuesdays. I think the next one on next Tuesday will be from the residential wholesale team, and then Brett and I will be back after that one. There was one question I think that popped up. It says, will the commercial Takeo After Dark be offered in the fall? And I think the answer to that is we probably will. We'll see how the first batch of Takeo After Dark presentations go, and if it's well received and people like it, then we'll continue with it. So yeah, I would say that. So thanks so much, and I'm going to say goodbye for now, signing off. Have a great week, everyone, and thanks so much for participating. Take care
Bye,
now.
everybody.